Hello everyone, my name is Chen from Beijing University of Post and Telecommunications. In this video, I will talk about our latest paper, CelebHair, a new large-scale dataset for hairstyle recommendation based on CelebA. Okay. So, why this paper? Let's first talk about the motivation of this paper. The context is, our team is currently working on a mobile application for hairstyle recommendation and try-on. We did look into some algorithms for visual image manipulation and the recommendation systems, and we believe that this application is actually feasible. However, the problem is we lack proper datasets for building such a system. Like any other modern mobile applications, our application is heavily driven by data. The quality of data we have is a primary factor that affects the quality of our application. Ideally, the dataset should have abundant facial images and other labeled features, so that with these features and images, we could build this recommendation and trial system. We found various hairstyle-related datasets that are publicly available on the internet. However, the real challenge is very little, or let's just say none of these datasets fit our requirements exactly. So our solution is to build one dataset ourselves, which leads to this paper, CelebHair. Before diving into the main content of this paper, let's first talk about some previous works that might be relevant. We did mention that we found some publicly available datasets on the internet, but none of these datasets actually fits our requirements. So, what's our requirements and why these datasets have failed to fit our requirements? In this section, we'll talk about 3 datasets that we believe are important, and we will come to summarize what we believe makes a proper dataset for hairstyle recommendation and trial. Okay, the first dataset is Beauty Expert, which was introduced in the paper Huang, You Are So Beautiful Today in 2014. Although this dataset do contain features like hairstyle, face shape, and other facial features that we believe are quite useful, it also contains features like lip gloss, foundation, eyeshadow, which are more related to beauty but not hairstyle. However, the most important obstruction of adopting this dataset is that it contains around 1,500 female things only. The limited volume and the gender diversity has also limited its application. The second dataset is Hairstyle 30,000, which was introduced in the paper The Need to Generate and Edit Hairstyles in 2017. As its name indicates, Hairstyle 30,000 is a dataset specifically designed for hairstyle-related tasks. It contains around 30,000 facial images and a really wide range of hairstyles, covering both male and female. However, apart from the facial images and their corresponding hairstyles, no any other features is available in this dataset. The lack of facial features has prevented the development of our hairstyle recommendation system. So, we also say no to this dataset. The third dataset is CelebA, which is a famous benchmarking dataset for computer vision tasks. It contains around 200,000 facial images of celebrities, as well as their corresponding level of facial features. However, some vital features are missing from the dataset, for example, hairstyle and face shapes. Therefore, we are unable to apply this dataset for building our hairstyle recommendation and trial system. So, in conclusion, what we need is a dataset with a large number of facial images as well as their corresponding hairstyle, face shape, and other facial attributes. Also, the dataset should be diverse enough so that it covers different genders, different hairstyles, different face shapes, and so on. We decided to build our dataset on top of CelebA given that it has the largest number of facial images. Despite some vital features missing, we adopted multiple approaches to extract these missing features from the facial images of CelebA, which will be covered in the next section. In this section, we will talk about how we build our dataset CelebHair on top of the CelebA dataset. So, first of all, we inherited all the facial images of celebrities from CelebA. However, the features of these facial images need to be altered. We classify our features into 4 categories based on how these features are collected. The first part is those features we also inherited from CelebA, which includes age, gender, attractiveness, and so on. Note that here, attractiveness is an especially helpful feature when you are trying to build a hairstyle recommendation system. The second part is a face shape feature. Face shape is what we consider the most important factor in deciding one suitable hairstyle. The third part is the hairstyle feature. Hairstyle is of course the most important feature in our dataset as we are building a hairstyle dataset. The first part contains other various features that we consider important but missing from the original CelebA dataset. These features are calculated based on the facial landmarks we extracted from the celebrity faces. So, for face shape, we trained the face shape classifier using the Yutao V4 network architecture. The trained dataset we used was acquired from Kaggle, which is a smaller dataset containing 5,000 facial images. These facial images are classified into 5 categories, which is hard face, oblong face, oval face, round face, and square face. Each category contains exactly 1,000 facial images. So we train this face shape classifier using this smaller dataset, then apply the classifier to the larger CelebA dataset. The result of our face shape classifier is quite optimistic. If you take a look at table 1, you can see that the overall precision of our classifier is around 95%, with the highest 98% precision in hard shape and oblong shape faces, and the lowest 90% precision in oval shape faces. Also, please take a look at table 2. You can see that compared to other existing approaches towards facial classification, our approach using the Yutao V4 neural network has seen a great performance improvement, with the accuracy increased by around 20%. Let's continue to the hairstyle part. So, for hairstyle classification, we train a hairstyle classifier using a convolutional neural network with a spatial transformer network substructure. So, please take a look at the image on the left side. You can see that between the first input layer and the second convolutional layer, there is a sub-neural network inserted in between. This is what we call a spatial transformer network substructure. A spatial transformer network is a specialized kind of convolutional neural network that can learn a affine transformation from an input image, so that the convolutional neural network that follows could be invariant to rotation scale, dropping, and so on. In our case, spatial transformer network help us focus on a very specific part of the input image, that's the hair part. The other parts like eyes, nose, mouth will be discarded so that they can no longer interfere with the classification process. Our experiment results have shown that the accuracy of our classifier has improved greatly with a spatial transformer network. The dataset we use to train the hairstyle classifier is hairstyle 10,000. Hairstyle 10,000 is a simplified version of hairstyle 30,000. It's a subset of hairstyle 30,000 with the 10 most popular categories of hairstyles. Apart from face shape and hairstyle, we have also extracted various other facial attributes from facial landmarks. 68 facial landmarks are annotated on each of the input visual image, as you can see in the image on the left side. Arithmetic operations are then performed upon these facial landmarks to extract facial attributes. Take forehead width, for example. We first calculate the distance between the leftmost forehead point and the rightmost forehead point. The distance between these 2 points are then divided by the total width of the entire face. Note that here the denominator is very important because absolute distance is sometimes very misleading, and we need this denominator as a regularizing term. So, until now, we have finished all the steps to collect data for our CelebHair dataset. It's time to take a look at the dataset. The CelebHair dataset contains around 200,000 facial images of celebrities, which is exactly identical to those of CelebA. Each facial image is labeled with 22 features. In the 2 images below, you can see the distribution of facial images among different face shapes and different hairstyles. These distributions are not exactly even, but to some extent we believe that this reflects the distribution of face shapes and hairstyles in real life. In this page, we list all the attributes in our dataset as well as their corresponding options in Table 5. Now that the data is collected, we try to build a hairstyle recommendation and try-on system using the CelebHair dataset. For hairstyle recommendation, we use the random forest algorithm. Remember that the attractiveness feature is especially helpful when you want to build a hairstyle recommendation system. Here we made an assumption that if a given facial image is considered attractive, then its hairstyle and corresponding facial attributes must be a good match. Such good matches are then fed into the random forest as trend data. We fine-tune the hyperparameters of random forest and ended up with 50 decision trees in the forest, each of max depth 5. The accuracy of the model is quite promising at around 90% on the trend set. For hairstyle trial system, we are currently using a deepfake-alike technique. For example, if a user wants to try on a certain hairstyle, she must upload a facial photograph of herself first, which gives us image B. The system will try to pick up a reference model image with the target hairstyle, which gives us image A. Now, we try to use the deepfake-alike technique to transfer the face of image B onto the face of image A, which gives us the result, image C. The result of such technique is quite unnatural, and even worse, It alters the primary factor in hairstyle choice, face shape. Therefore, for future work, we are planning to use a generative adversarial network to improve the user experiences of our hairstyle trial system. For example, Interface Scan is a latest research project that helps us edit the human faces generated by a GAN through linear manipulation. As you can see from the image below, Interface Scan is capable of editing the human faces, age, expression, and so on. The Interface Scan was trained up on the CelebA dataset, so we can't help but wondering, what if we train the Interface Scan on our CelebHair dataset so that we could have a GAN that is capable of editing a user's facial images hairstyles?